Hello class, welcome to Unit 5, Video 6. Today we're going to look at Venn diagrams and averages. Your learning targets are that you can find probabilities from a Venn diagram and that you can calculate weighted averages. So, example 1, in a survey, 100 adults are asked whether they like coffee, which is C, so this circle right here is representing coffee, and whether they like tea, which is this circle right here. The Venn diagram shows the results of the survey. Okay, so a few things that we need to talk about. This is the people who like coffee. This is the circle that represents people who like tea. So what this means is that the middle circle is the people who like both coffee and tea, just so that you understand how that works. So those are people who like both. Okay. So really, the number of people that like coffee would be 46 plus 13, which would be 59. So we'd have 59 people like coffee, and here would be our total number of people who like tea. Okay. Then when you talk about the 16, the people on the outside of those circles, that means they like neither. They do not like coffee, and they do not like tea. So it says a person is chosen at random. Find the probability that the person does not like coffee. Okay, so let's figure out how many people like coffee. It's 13 plus 46, which is equal to 59. So 59 people like coffee. So then the people who do not like coffee like coffee. Well, there's 100 people, so it's going to be 100 minus 59, which gives us 41. Okay, so 41 people do not like coffee, but we want to do the probability. So the probability that you do not like coffee would be 41 out of 100. And that would be our probability. Okay. Part B says a person who likes tea is chosen at random. Okay, so that means we're strictly only looking at the people who like tea. So we're looking at this circle here. Okay. Find the probability that the person also likes coffee. So what we need to do is figure out how many people like tea. Our people that like tea are 46 plus 25. So the tea people are 46 plus 25, which tells me that there's a total of 71. Okay, so we're choosing from this group. Find the probability that they also like coffee. So this is the people that like both coffee and tea. So it's a 46 out of 71 probability. Okay. And then part C says 2 people are chosen at random. Find the probability that they both like coffee. Well, if we go back, the people that like coffee, there's 59 out of 100. So 59 out of 100. This is my first person. So I'm choosing one person, and then I'm going to choose another person. So which means there's one less person to choose from, okay? And we want them to both like coffee. So if I pick somebody that likes coffee, then there's only 58 to choose from, okay? If I multiply this out, I get 3,422 over 9,900. And if I reduce that, it's 1,711 over 4,950, okay? So it could be that as a reduced fraction or 0.346. And the ones from part A and B you could put as decimals if you wanted to as well. That is up to you. Okay, so that is our Venn diagrams. Example 2, this is going to be finding an average or a mean. So Isabella went up and down the street to find out how many parking spaces each house has. Below are her results. What is the average number of parking spaces? Okay, so I have seen this type of problem on the ACT before, so you need to be aware of it. So what it really is how many total people did they survey? Well, the frequency is there was 15 houses with 1 parking space, 27 with 2 parking spaces, 8 with 3, and 5 with 4. Okay, so how many total houses? I would add up my frequency. So the total number of houses that were checked was 55. Okay. Then we need to figure out, to find the average, we have to add up all the number of parking spaces. Okay, so what this piece of data here means is there was 15 houses with 1 parking space. So 1, 1, 1. And you would have to list out 1 15 times. Okay, so To find an average, remember you add them all up and divide by the total number of numbers. So the way you can do this is to figure out, well, 15 times 1 is 15. So I added up this column. Here, there would be 2 listed out 27 times. This is why they used a frequency table, because they didn't want to list out a 2 27 times. So to figure out how my total for this column, it would be 2 times 27, which is 54. Okay. So in order to get out the total number of parking spaces when you add them all together, we would have to multiply. So let's just go ahead and write it a little bit nicer. So we have 1 times 15, which is 15. 2 times 27, which is 54. 3 times 8, which is 24, over 4 times 5, which is 20. Okay, so that is just essentially taking 1 plus 1 plus 1 15 times. There was 27 twos, so 2 plus 2 plus 2, 27 times. And then there's 8 houses with 3 spaces, so 24 total. So what we need to do is add these together. Okay, and when I add these together, 15 plus 54 plus 24 plus 20, that would be my, my numerator for finding the average. Okay, so when I add these together, I get 113. Okay, so in the neighborhood total, there's 113 parking spaces for 55 houses. Okay, so my average, remember the average is the same as the mean, is 113 divided by 55. So if I divide that out, I get 2.055. And what is this talking about? Parking spaces. So it's saying on average, a house has 2.005 parking spaces. Okay, that is example 2. So finding the average from a frequency table. If you have any questions, please let me know. Otherwise, I'm going to move on to weighted averages. Weighted averages are another item that have popped up on the ACT exam, so we want to make sure you're prepared for that. So example 3. The final grade for a class is calculated by taking 75% of the average test score and adding 25% of the score on the final exam. Okay. If all score is out of 100 and a student has a 76 test average, what score do they need on the final exam to have a final grade of at least 80? So we don't know the score for the final exam, so I'm going to use X. So what we need to do is we take 75% and we write it as a decimal, so 0.75, times the test score average. Our average test average is 76. And adding, so plus 25% of the score on the final exam, which we don't know, so X. And it has to be at least 80. Okay, so to be at least 80, that means this has to be greater than or equal to 80 in order to get that 80 in the class. So what we need to do is simplify. So 0.75 times 76 gives me 57, plus 0.25x is greater than or equal to 80. You would subtract 57 and get 23 from both sides. And then we would divide by 0.25. So x is greater than or equal to 23 divided by 0.25 would be a 92. So what that means is that student needs to get a 92 or a 92%. X has to be greater than or higher on their final exam to get a grade of an 80. Okay. So this would also work for you when you get closer to your final exam and you want to know what you need to get. You can use this type of idea. Okay. So example 4, the final grade for your Algebra 2 class is calculated by taking 70% of the average test, 15% of the average homework, and 15 on the score on the final exam. Okay. If Ronald's current test score is an 87 and homework is a 96, okay, part A, what does he need on the final exam to have a final grade of at least an 90%? Okay. So before we use whole numbers, okay? That's fine as long as you keep these all whole. This time we're going to go ahead and use all decimals, okay, just so you can see how it works both ways. So 70% on an average test, so 0.7. Current average test score is 87, so times 0.87, plus 15% of the average homework. Homework is a 96, so 0.96, plus It's 15% on the final exam, so 0.15. They didn't tell us that. That's what we're trying to find out. So x. And we want to have at least a 90%. So that means this has to be greater than or equal to. 90% is a 0.9. So we go ahead and simplify. 0.7 times 0.87 is 0.609 plus 0.15 times 0.96 is 0.144 plus 0.15x is greater than or equal to 0.9. Okay, I go ahead and I'm going to add these two together and I get 0.753 plus 0.15x is greater than or equal to 0.9. So I'm trying to solve for x. So I would subtract this from both sides. And I have 0.15x is greater than or equal to, when I subtract it, I get 0.147. And then I would go ahead and divide both sides by 0.15. So x is greater than or equal to, when I divide this out, I get 0.98. Okay, so what does this mean? This is his final exam score. So if he wants to get an A, a 90%, he would have to get 0.98 is really a 98% on his final or higher to get that A. Okay. Moving on to B. All right. This piece is still exactly the same, but now we're saying what does he need on the final exam to have a final grade of at least 93%, an A+. So what I'm going to do is I'm actually going to go back to my last problem, and we are just going to change this piece. Okay, so all the scores up to this point are the same, and this is just simplifying. So this has stayed the same. I'm just going to copy this piece. And bring it to the other side. We're going to start out with that. Because you could plug it all in and simplify and you'll still get the same. Maybe it'll let me move it. All right. Okay, the only difference is we were solving before for a 90%. Now he wants at least a 93%. So I need to change it. It needs to be 93. Okay, so from here I solve it the same way though. Greater than or equal to, subtract this, and you get 0.177. You divide by 0.15 on both sides, and you get x is greater than or equal to 1.18. Okay, well, what is that as a percent? Seems like it's not right. It's 118%. So what it's saying is he would need to get 118% or higher on his final exam. Can you get above 100% on your final exam? No. So this is, which is not possible. So Ronald, so therefore, this is math symbol for therefore, he cannot get an A+. He can get an A, but it's going to be hard. He has to get a 98. So clearly it's going to be hard for him to get a 93% if he has to get a 98 just to get an A. Okay. All right, one last type of average problem. Okay. John's college math grade is determined by taking the average of 5 tests. Okay. He has his first scores for his first 4 tests, 87, 85, 93, and 88. What does he need to get on his 5th test to get a B, which is an 80%? Okay, so we need to find the average. So to find average of the 5 tests, we take our 5 scores and add them together. So I would have an 87 plus an 85 plus a 93 plus an 88 plus, we have 5 test scores. We don't know what the 5th one is, so plus x over how many scores? There's 5. We want it to get an 80, so out of an 80. 80%, okay. Notice how these are not in percents. This is really an 80 out of 100, so we're going to say 80. These are 87 out of 100, so it's an 87%. Okay, so let's go ahead and solve this. First thing we're going to do is add these numbers here together. So when I go ahead and add them, I get 353 plus x over 5 is equal to 80. Multiply by 5 on both sides. So I get 353 plus x is equal to 400. Subtract 343 from both sides, so x equals 47. So John has to get a 47 out of 100 or a 47% in order to get a B. So I think that should be probably pretty doable for John, considering most of his tests were in the 80s. Okay. That is it for Unit 5, Video 6. If you have any questions, let me know. Otherwise, have a great day, and I will talk to you later.